Hello students, welcome to the Quick Solutions All India Cast Test Series JEE Advanced 2021 Test 1A Paper 2 Physics. Let's go to question number 1. Question 1 says, a car accelerates from rest at a constant rate alpha for some time, after which it deaccelerates at a constant rate beta to come to rest. If the total time elapsed is t, then the statements are the maximum speed the car would attain is this much. Option B says the maximum speed the car would attain is this much. Option C says total displacement of the car is this much. Option D says total displacement of the car is this much. Well, it's a question from Kinematics, motion in a straight line with uniform acceleration. Now, to get the situation clear, we can try and draw a velocity time graph for this particle, and that graph will look like this. Let's say this is velocity time. It starts at t equal to 0. It has uniform acceleration a for some time. Let's say, so for some time it goes, its acceleration is alpha. Let's say this time is t naught, and so here the velocity will become alpha t naught, and then it deaccelerates to rest. Let's say deaccelerates to rest, so it's a straight line again, and t is the total time. Then we have alpha t naught. At this point velocity is alpha t naught, and here it is again at rest, and deacceleration is beta. So we have the equation alpha t naught minus beta. Total time is t, so that means t minus t naught is the time it gets to deaccelerate to rest. And solving, what do we get? We get alpha plus beta t naught is equal to beta t, and which means t naught is equal to beta t upon alpha plus beta. So the maximum speed attained is at this point, and Vmax then will be simply alpha t naught. That means alpha beta t upon alpha plus beta. Let's look at the options. This is matching with option B, so option B is correct, and option A is incorrect in that case. Let's now find the total displacement the car has. Obviously the total displacement is area under velocity time graph, and that area is equal to base, which is half into base. Base is t, and the height is alpha t naught. We substitute the value of t naught from here, and then it is equal to half alpha t. Instead of t naught we write beta t divided by alpha plus beta, which is equal to alpha beta t square by 2 into alpha plus beta. Let's look at the options. It is matching with option C, so option C is correct. Option D is incorrect. So let's go to the next question now. Question 2 says two blocks of mass 5.0 kg and 10.0 kg are placed on a fixed inclined plane, and they are connected by a light string. The inclined plane makes an angle 37 degree with the horizontal. Both the blocks are released simultaneously from rest, and at that time the string was just straight without any tension. Take g equal to 10 meter per second square. Choose the correct options. Option A says if mu1 is equal to mu2 equal to 0.5, then tension in the string is T equal to 0 Newton. Well, in this case both the blocks will slide, and since coefficient of friction for both the blocks is same, so both the blocks have the tendency to come with the same acceleration, and hence there will be no tension in the string. So the option is correct, which means option B is incorrect. What happens in case of option C when mu1 is equal to mu2 is equal to 0.8? Then what is the tension in this case? Well, in this case, neither block will have the tendency to slide down the incline because the angle 37 degree will be less than the angle of repose, right? So the minimum angle required in this case to make the block slide will be tan inverse of 0.8, and we know tan 37 degree is only 3 by 4 or 0.75. That means this angle 37 degrees is less than the angle of repose, which means both the blocks will remain stationary and tension will be 0. So option C is also correct. Option D says if mu1 is 0.4 and mu2 is 0.6, then tension in the string is this much. So this we have to calculate. Let's calculate now. So for the 5 kg block, the equation will be, we know the forces are 5G, then here there is a normal reaction N1, there is a friction F1, and there is tension T. If we resolve and write the equations, we get 5G into sine 37 degree minus friction will be mu into N1, that means it is 0.4 into 5G cos 37 degree minus tension T is equal to 5A, right? And the other equation for the 10 kg block, here the coefficient of friction is more, so we get 10G sine 37 degree minus 0.6 into 10G cos 37 degree, and of course there is T also pulling it this way, so T plus this is 10A. To find tension, we divide second equation by the first equation. So on the right hand side we get 2, on the left hand side we get T plus 10G sine 37 degree. How much is that? This is 0.6, this is 6G, minus this is 0.8, so this is 4.8G, divided by, again this is 3G, minus this is 0.8, so 0.8 into 5 is 4, 4 into 0.4 is 1.6, 1.6G minus T. Let's simplify further. So this will be 1.4G, so that means 2.8G minus 2T is equal to T plus 1.2G. Solving, we get 3T is equal to 1.6G or 16 Newton, and T itself is equal to 16 by 3 Newton, which means option D is correct. Let's go to the next question now. Question 3 says a body thrown vertically up from the ground passes the height 16.45 meter twice in an interval of 4 seconds. Then its initial velocity is this much, its initial velocity is this much, maximum height from ground level is this much, and total time of flight is 5.4 seconds. Okay. Using the equation y is equal to uyt plus half a yt square, we get 16.45 is equal to ut minus 5t square, or 5t square minus ut plus 16.45 is equal to 0, and the roots are given by u plus minus under root of u square minus 4ac, that means 20 into 16.45 divided by 10. So this means T2 minus T1, that is 4 seconds, is equal to under root of u square minus 20 into 16.45 divided by 5. This means 20 square is equal to u square minus 20 into 16.45. Solving for u, we get u is equal to 27 meter per second, which means option B is correct. How about the maximum height from ground and total time of flight? Well, total time of flight is 2u by g, 2u by 10, and that is equal to 2 into 27 by 10, which is 5.4 seconds. So option D is also correct. Let's check option C now. So for maximum height, we get h max is equal to u square upon 2g, and that means it is 27 into 27 divided by 2 into 10. How much is this equal to? Let's calculate. On calculating, we find h max is coming out to be 36.45 meter. Of course, you have to do the calculation, do the multiplication and divide. And we find option C is also correct. So for question 3, options B, C and D are correct. Let's go to question number 4 now. 4 says the position of the particle varies with time as r is equal to this much. Then angle between velocity and acceleration is pi by 2. Particle moves with constant speed along z direction. Total distance traveled by the particle in the interval when it makes one complete revolution in xy plane is this much, and total distance traveled by the particle in the interval when it makes one complete revolution in xy plane is this much. We first find expression for velocity. Let's get velocity by differentiating r with respect to t. So velocity v is dr by dt. In this case, it is 2a cos 2t I cap minus 2a sin 2t j cap plus b k cap. And acceleration a is dv by dt, and that means it is equal to minus 4a sin 2t I cap minus 4a cos 2t j cap. If we take the dot product of v and a, which we frequently do to find angle between two vectors, if we take the dot product, we get this as 0, which means the angle between velocity and acceleration is pi by 2. That means option A is definitely correct. Let's look at the other options. Particle moves with constant speed along z direction. Well, there is a component of velocity along z direction, which is b, and there is no acceleration. Acceleration is always in the xy plane. It has only x and y components. So which means the velocity along z direction will be constant, and so option B is also correct. Particle moves with constant speed along z direction. Option C and option D are about the distance traveled. Total distance traveled by the particle in the interval when it makes one complete revolution in xy plane is. The time taken to complete one revolution, capital T, we'll find is equal to 2 pi by 2, or it is simply pi second. Why it is so is this. Basically, if you look at the component of r in the xy plane, it's like this. If we draw a circle, then the component of r in the xy plane is basically a sin 2t. That means a vector of length a with origin at the center, if it's rotating, with omega equal to 2 radian per second, let's say, or 2 units, then this angle will be 2t. If at t equal to 0 particle was here and it's moving like this in the xy plane, then we have r as a sine 2t I cap plus a cos 2t j cap. So that means the angular speed of this radius vector is 2 radian per second, omega is 2 radian per second, and so time taken to complete one revolution is 2 pi by 2 or pi second. Now this is the time taken to complete one revolution. Now what is the total distance traveled? So displacement along z axis will be simply b into t, that means pi b. So let's say displacement along z axis is pi into b, and the distance traveled in the xy plane will be 2 pi r, that means 2 pi a. So if we take the total path length will be under root of 2 pi a whole square plus pi square b square. If we take pi as common outside, we get pi under root 4a square plus b square, which is matching with option C. Option C is also correct. That means for question 4, options A, B and C are correct. Let's move to the next question now. Question 5 says, in the figure shown, mass A is placed on rough inclined surface of wedge B and wedge B is placed on smooth horizontal surface. If N be the normal force of contact between A and B and Fr be the friction force between A and B, then option A says if B remains stationary, then A will also remain stationary. Option B says if B remains stationary, then N sin theta is equal to Fr cos theta. Option C says if B moves, then N is less than mg cos theta. And option D says if B moves, then N is greater than mg cos theta. Let us try to do it analytically without quantifying things as far as possible. Now, if B is stationary, let's get the situation very clear. So this surface between A and B is rough and B is placed on a smooth horizontal surface. If N be the normal contact force between A and B and Fr be the friction force between A and B, then if B remains stationary, then A will also remain stationary. Now if B remains stationary, that means the contact force between A and B is vertical. There is no horizontal component to it. That is the only case when B can remain stationary. Now if the contact force between A and B is vertical, then obviously A will also remain stationary. It will remain in equilibrium. So that means option A is correct. Statement A is correct. Let us look at statement B now. If B remains stationary, then N sin theta is equal to Fr cos theta. Then now we need to, of course, draw the free body diagram. As I told you, when B is stationary, the contact force between A and B is vertical. So if I look at ABD of A, there is this force mg, there is this N, and there is this friction. So horizontal components of N and F cancel each other. So if I draw this horizontal line, this angle is also theta and this angle is also theta. So if the horizontal component of N and F cancel, we get the equation N sin theta is equal to Fr cos theta, which means option B is also correct. Let's look at statement C now. It says if B moves, then N will be less than mg cos theta. And if B moves, then N is greater than mg cos theta. See, when B moves, obviously if B moves, it will move towards right, and which means the normal reaction between A and B, which means the normal reaction between the block and the wedge, will be less than mg cos theta. Normal reaction is mg cos theta when B was not moving at all. Now since B is moving, so the normal reaction now will definitely be less than mg cos theta. That means option C is also correct. Let's go to the next question now. Question 6 says, it is given that the velocity of the body is constant during its motion, then which of the following statements are correct? Instantaneous modulus of, or the magnitude of instantaneous velocity vector is equal to instantaneous speed. Well, this is always correct, so there is no doubt about this. This statement is correct in all situations, that instantaneous speed is nothing but the magnitude of instantaneous velocity. Now in our case, the velocity is constant. Let's look at option B now. It says modulus of average velocity vector is equal to instantaneous speed. Now when velocity is constant, then average velocity is same as instantaneous velocity at any time, which is equal to instantaneous speed. So option B is also correct. Let's look at option C. It says instantaneous velocity vector is equal to average velocity vector. That is also correct because the velocity is constant, so its average value and its instantaneous value will be equal, and the average speed will also be equal to instantaneous speed. So option D is also correct. That means for question 6, all the 4 statements are correct. Let's move to the next question now.